Okay, now we discuss about squares and square. So in the first one, squares. So we discussing about squares. The square of the number is the product of the number with the number itself. The square of the number is the product of the number with the number itself. Suppose I take 4 square. So I take 4 square. So the square of the number, so that is 4 square, is the product of the number, the product of that number with the number itself. With the number itself. So 4 into 4. So 4 square is 4 into 4. So 4 raised to the power 2. 4 raised to the power 2 or 4 raised to 2. So you read it as 4 raised to 2 or 4 to the power 2 or 4 square. Okay. So in that 4 act as the base and 2 act as the exponents. We call it as 2 as exponents and 4 as base. So I given so many examples here. You see that. So 1. So A. Suppose you take A. So A is any number. So the square of the number is A square. So that means A into A. That is A into A. A square means A into A. So I take 1. So 1 into 1 you get 1. 2. 2 into 2, 4. 3. 3 into 3, 9. 4. 4 into 4, 16. 5. 5 into 5, 25. So next 6 you take. 6 into 6, 36. You see that A, here it is A square. So that means 6 into 6, 36. 7 into 7, 49. So 8 into 8, 64. So 9 into 9, 81. Similarly 10, you get A square from 100. So 11 square, 121. So 12 square, 144. 13 square, 169. 14 square, 196. So you see that 4 into 4 it is 16 no? So like this. 15 square, 225. 16 square, 256. 17 square, 289. 18 square, 324. And 19 square you get 361. And 20 square you get 400. So you know now. So 4 is a base and 2 act as the exponent and 4 raised to the power 2. So that means 4 into 4. So that is equal to 16. So that is, you take any example, 3 square if you take, so that you get 9. So that means 3 into 3. So next we have the problem. Is 576 a perfect square? We have to do that. Is it 576 a perfect square? If so, find the number whose square is 576. So we have to find that number. So whose square is 576. So first we have to do that 576 is a perfect square. So perfect square means, so you see that 400 or 1, 4, 9, 16, 25. So these are all perfect squares. So 1, 4. Suppose I take 3. Okay, 4. Why you call it as 4 is a perfect square? So I write here only. Okay, 4. 4 can written as 2 into 2. You have two same factors. So therefore 4 is a perfect square. So if you consider 3 is not perfect square. Since 3 cannot write in the form of the same factor. So now we have to prove that 576 is a perfect square. So find the number whose square is 576. So we have to go through prime factorization. So first you know that. So what is a prime number? So first you know that. So what is a prime number? So 2, 3, 5 and 7, 11. These are all prime numbers. So why you call it as prime numbers? 2 can be written as 2 into 1. So the only factors 2 and 1. So 3 can be written as 3 and 2, 1. 3 into 1. So the only factor is 3 and 1. Suppose I take not prime. So you call it as composite number also. So 4. So 4 is not a prime. So 4 can be written as 2 into 2 and 4 into 1 also. So there is one extra factor. So that is 2. Clear? Total you have 1, 2, 3 factors. So So you have two factors. So the one is 1 and one is the number itself. So the prime number is a number. So prime number is a number. It has only two factors, 1 and the number itself. So that you call it as a prime number. So 4, 6, 8. So these are all not a prime. So now we have to divide this number using prime factors. So now we have to divide this number using prime numbers. So first I take 2. Since it is even, so it is divided by 2. 2 2s are 4. 1 carry is 17. 2 8s are 16. 2 8s are 16. 1 carry. 2 8s are 16. So next to 2. So since it is even, so 2 1s are 2. 2 4s are 8. 2 4s are 8. So one more time it is even. 2 7s are 14. 2 7s are 14. And 2 2s are 4. So next to 2 one more time. So 2 3s are 6. So 1 carry is 12. So 2 3s are 6. 1 remainder 12. 2 6 are 12. So next you go through one more time. 2 1s are 2. 1 remainder. 2 8s are 16. So next one more time. 2 9s are 18. So next 3 3s are 9. 3 1s are 3. So now 576 can be written as 2 into 2 into 2 into 2 6 times, right? So 1 2 3 4 5 6. So 1 2 3 4 5 6 and 3 into 3. Clear? So you write. So it can be written as, make it a pair. Okay. So you have 4 pairs. So one is 2. One is a number 2 into 2. One more is 2 into 2. 2 into 2 and 3 into 3. So therefore, it is a perfect square. So 576 is a perfect square. So now you prove that the number whose square is 576. We have to find the number. The square is 576. We have to find that number. So you know that 576 can be written as, so this 2 into 2 you can written as 2 square into 2 square into 2 square into 3 square. Clear? So 2 square means 2 into 2, 2 square 2 into 2, 3 square 3 into 3. So now 2 into 2 into 2 into 3. So put the square outside the bracket. So 2 2s are 4, 4 2s are 8, 8 3s are 24 square. 24 square. So 24 square you get 576. 24 square you get 576. Therefore, square of 24, the square of the 24 is 576. So now you see that properties and patterns of a square numbers. So we have to see that properties and patterns. There are some properties for squares and some patterns exist for the squares. So in that first one, the numbers which ends in 2, 3, 7 or 8 is never a perfect square. So the numbers which ends in 2, 3, 7 and 8 is never a perfect square. You see that one example. So 1 square. 1 square is 1. 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25, 6 square, 36, 7 square, 49, 8 square, 64, 9 square, 81 and 10 square, 100. You see that? The last digit, so 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. So you not get 2, 3, 7 or 8. So if you get 2, 3, 7 or 8, so suppose you take 12. 12 is not a perfect square. 12 is not a perfect square. If you take 16, 16 is a perfect square. So the number ends with 1, 4, 9, 6, 5, 6, 9, 4, 1. So these are all the perfect squares. So the number ends with 2, 3, 7 or 8. It is not a perfect square. square. So now you see that second property, the unit digit of the numbers. We have to concentrate on unit digits. So in that number, you take 25. So 5 is the unit place and 2 is the 10th place. So 5 is the unit place and 2 is the 10th place. So unit digit of the number. So if it is 0, you take 10. So if it is 0, the unit digit of the square number is also 0. The unit digit of the square number. So this is a square number. So this is the number. So this is 10 is the number. So 100 is the square number. So that is also 0. So the if unit digit of the number is 1 or 9. So if it is 1 or 9 unit digit. So I take only one number. Suppose it is 11 and here it is 90 like this. Okay. Suppose it is 1 and 9. The unit digit of the square number is 1. The unit digit of the square number is 1. You see it here and 9. That is 81. 81. So you see that 1. So next, if it is unit digit of the number, it is 2 or 8. So 2 or 8. Then it is ends with 4. Ends with 4. You see that 4, 64. So if it is 3 or 7, 3 here. So that is 9. 7 it is 9. You see that. Okay, if it is 4 or 6, so 4 here, that is 16. So you see that it is 6. The unit digit of that square number, it is 6. Okay, and one more number, it is 6, 36. That ends with 6. Okay, lastly you have 5. So 5 square 25. So that ends with 5. So that is about the second property or pattern. So now you go through third one. The number of zeros at the end of the perfect square is always even. So the number of zeros at the end of the perfect square. Suppose any number so ends with a zeros. So always even number of zeros. You have even number of zeros. So 10 square, you see that is 100. 10 into 10, 100. So 30 square. So you have 2 zeros. Even number of zeros. So even number of zeros. Okay. And if you take 500 square. So 5 5s are 25. 2 0 2 0. So total even number of zeros you have. So the number of zeros at the end of the perfect square is always even. So you see that here 2, here 2, here it is 4. So these are in the form of even number. So okay. So 230 you have only 1 0 and here you have 3 0. Odd number of zeros. It cannot be a perfect square. So 230, 5000, 3000, 1000. Okay. So 50. So these are all not a perfect square. So finally, the square of an even number is always even. The square of even number is always even. You take 4 square, 16. So 4 square means 4 into 4, 16. Okay, 8 square. So that is 8 into 8, 64. So it is even. So the square of the even number is always even. Okay, next fifth property. The square of an odd number is always odd. The square of an odd number is always odd. So take an example. So 1 square is 1. So 3 square is 9. So 3 square means 3 into 3. So that is 9. So 9 square is 9 into 9. So that is 81. So next you take 5 square. So 5 into 5. So that is 25. So see that you're taking all odd numbers and you get all odd. See that 1 square is 1. 3 square is 9. 9 square is 81. Okay, next sixth one. The difference between the square of two consecutive natural number is equal to the sum of the number. The difference between the square of two consecutive natural numbers is equal to the sum of the numbers. So the difference between the two consecutive numbers, okay. So that is 5 square minus 4 square or 3 square minus 2 square, like that. Okay, 5 square minus 4 square is equal to 5 plus 4. So they told 5 square minus 4 square is equal to 5 plus 4. So 5 square is equal to 25. 4 square is minus 16. So 5 plus 4 you get 9. So 25 minus 16 you get 9. So 9 equal to 9. So that is true. So in the case of 37 square minus 36 square you get 37 plus 36. So is equal to 73. So according to this one, the difference of any two the squares of consecutive natural numbers is equal to the sum of the numbers. Okay, next, seventh property, the sum of the first n odd natural numbers is equal to n square. The sum of first n odd natural numbers is equal to n square. We take an example. So 1, 3, 5. You see that all are odd numbers. The sum of all odd numbers, first n odd numbers, 1, 3, 5. So 1 plus 3, 4, 4 plus 5, 9. So 9 is a square of 3 square. So 9 equal to 3 square. So that means 1, 2, 3, 3 square. So 1 plus 3, 4, 4 plus 5, 9. Similarly, you see that 1 plus 3, 4, 4 plus 5, 9. So 9 plus 9, 18, 7 plus 11, 18, 18 plus 18 you get 36. So that is equal to 6 square. So 1, 2, 3, 4, 5, 6. So first n odd numbers, the sum of the first n odd natural numbers is equal to n square. So that is 36. So next property, the square of any odd natural number other than 1, the square of any odd natural number other than 1 can be expressed as the sum of two consecutive positive integers. The sum of two consecutive positive integers. You see that the square of any odd natural numbers, the square of any odd natural numbers. So you see that 3 square. So this is the odd. 3 square you get 9. So 9 can be written as sum of two consecutive numbers, 4 plus 5. So 9. Other than 1, you can't write 1. Okay. 5 square is equal to 25. You write it as 12 plus 13. 7 square you written as 49. So that is equal to 24 plus 25. If 1 is added to the product of two consecutive odd natural numbers, then the result obtained is equal to the square of the only even natural number between them. So if 1 is added to the product of the two consecutive odd natural numbers, that is a number two consecutive, means two continuous number. So that is 3 and 5 odd natural, 3 continuous odd natural. So that is 3 and 5, 5 and 7, 7 and 9, 9 and 11, like this. Okay. So 3 into 5 you get 15 plus 1, 16. So that is 4 square. That 4 square you see that. So that is the middle number of 3 and 5. So that is the middle number of 3 and 5. So that is 4 square. So similarly, so you see one more time, if 1 is added to the product of the two consecutive odd natural numbers, so it is a consecutive odd natural numbers, then the result obtained is equal to the square of the even natural number. So you get even here. So that is in between 3 and 5. So that is 4 square. Similarly, 7 into 9 plus 1. So 7 into 9 you get 63 plus 1, 64. So that is 8 square. So similarly, 11 into 13 you get 143 plus 1 you get 144. That is 12 square. So in between 11 and 13 you get 12. So next, 10th property. If 1 is added to the product of two consecutive natural numbers, so 1 is added to the product of the two consecutive even. So in the last type you get odd. So now it is even natural numbers. Then the result obtained is equal to the square of the only odd natural number between them. So okay, you take two even natural numbers, that is 2 and 4, 4 and 6, or 8 and 10, like this. Okay. So first I take 2 and 4. So 1 is added to the product of the two natural even numbers. So you get 2 4 the 8 plus 1 9 is equal to 3 square. So 3 in between 2 and 4 you have 3 square. Okay. So 8 into 10, 80 plus 1 81. So 9 square. Similarly 4 into 6. So 4 6 are 24 plus 1 25. So that is 5 square. So 5 exists in between 4 and 6. Okay, next property, 11th one. The sum of two consecutive triangular number is a square number. The sum of two consecutive triangular number is a square number. So first you see that what is the triangular number? So you see that. So first one dot. So itself is a triangular number 1. So if you 3 dots, so it will look like triangle, no? So 3 is a triangular number. So next 1, 2. So it is also look like a triangular. So you have how many dots? 1, 2, 3, 4, 5, 6. So that is also a triangular number. So 1, 3, 6, 10. Okay, like that. So you get triangular numbers. Is a square number. In that, we have to add consecutive triangular numbers. So 1 and 3, 3 and 6, 6 and 10. So this we call it as consecutive numbers. So 1 plus 3. So 1 plus 3, 4. So that is 2 square. So 3 plus 6, you get 9. So that is 3 square. So and 6 plus 10, you get 16. So that is 4 square. So finally you go to Pythagorean triplets. So Pythagorean triplets is very important. So that is in the form of m square plus n square is equal to t square. So Pythagorean triplets is in the form of m square plus n square is equal to t square. So 3, 4, 3, 4, 5. So one is 3, 4, 5. So next one 5, 12, 13. So one more 8, 15, 17, so on. You get so many Pythagorean triplets. So why you call it as Pythagorean triplets means, so you see that m square. So in that m square is 3. M is 3. So n is 4 and p is 5. You see that 3 square, 4 plus 4 square. 3 square plus 4 square. 3 square 9, 4 square 16. So 9 plus 16 you get 25. So 25 is equal to 5 square. So you know that m square, n square is equal to, there is one more, p square. Similarly, 5 square plus 12 square. So 5 square 25. So 12 square means 12 into 12. So that is 144. So 25 plus 144 you get 169. So that is the square of 13 square. 13 square you get 169. Similarly, 8 square plus 15 square is equal to 64 plus 225. So 64 plus 225 you get 289. So that is 17 square. So 17 square you get 289. So that means 17 into 17 you get 289. So for any natural number m greater than 1. So m greater than 1 means you have to take the value 2, 3, 4, 5, so on. So many numbers. So you not take 1. So we have 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square, where 2m, m square minus 1 and m square plus 1 are triplets. So in the place of m, I take 2. So m is equal to 2. So I take m is equal to 2. Then 2m is equal to, so 2 into 2. In the place of m, I take 2. So that means 4. The first number is 4. In the place of 2m, I have 4. So m square minus 1. So m I take 2 means m square means 2 into 2. So that is 4. So 4 minus 1. So that is 3. So next number is 3. So is equal to m square plus 1. So m square you got 4 plus 1. So that is 5. So you see here 2m you have 4 square plus m square minus 1 you have 3 square is equal to 5 square. So that is equal to, so the same relation what you have this one, 3 square plus 4 square is equal to 5 square. Similarly you get like this, you substitute. So now I substitute 2. So next you substitute 3. So next you substitute 4. So you get continue Pythagorean triplets using the equation 2m whole square plus m square minus 1 whole square equal to m square plus 1 whole square. So this is the triplets, this is the form of this one.